Dear friend, today we have Dr. Amjad Pathan sir with us to teach us chemical kinetics. Sir is assistant professor in the Adarsh College Hingoli. Now I request Dr. Pathan, Mr. Pathan sir to take the charge of this session. Pathan sir, please.
Okay, thank you, sir. Okay, welcome all of you. So today we'll learn. Now let's focus on the board.
Hello. Hello, Pathan sir.
Pathan, unmute yourself.
Hello.
Pathan sir.
Pathan sir, unmute. Hello, Pathan sir. Please unmute yourself. Hello.
Yes, sir.
Yeah.
Yes, yes.
Now, am I audible?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. You are audible.
So, the branch of physics. Okay. So the rate of reaction, study of rate of reaction is nothing but chemical kinetics. Okay. So the branch of physical chemistry which deals with the study of velocity of reaction or rate of reaction is called as chemical kinetics. Now, study of chemical kinetics involves first the rate of reactions, rate laws, rate of reaction, rate laws, then various factors. Okay, various factors that affect rate of reaction. And last, the mechanism of reaction. Okay, so you are studying chemical kinetics. That means you are studying rate of reaction, you are studying rate laws, you are studying various factors that affect rate of reaction, and lastly, mechanism of the reaction. Okay, then what is first point? Rate of reaction. Rate of reaction. Now, what is it? Okay. Screen वर दिसते का बरोबर properly?
Sir, दिसतंय.
Okay. Then, now what is rate of reaction? Now let us consider, for example, reaction. Say A gives B. Here A is a reactant and B is a product. Okay. Now what happens as the reaction proceeds? Okay. A reacts with the formation of B. Here A is a reactant and B is a product. So with time, the concentration of A continuously decreases, and that of product B, concentration of B is continuously increases. Okay. Now, if you plot a graph, say about concentration of A with time, then what happens? Concentration is continuously decreasing, and that of B, that is product, with time, the concentration of the product B continuously increases. Okay. Now, what is it? So as the reaction proceeds, the concentration of A is continuously decreasing and that of B is continuously increasing. Okay, so rate of this reaction is given as rate of reaction is equals to rate of reaction is equals to the rate of disappearance of A with time, or rate of appearance of B with time. Okay, की ज्या स्पीड ने अमाउंट ऑफ ए डिक्रीज होतो, ओके, तो स्पीड म्हणजे रेट ऑफ रिएक्शन, किंवा हा जो प्रोडक्ट बी आहे त्याची कॉन्सन्ट्रेशन कंटिन्युअसली वाढत जाते, सो त्याचा स्टडी, ओके, त्याची वेलोसिटी द फॉर्मेशन ऑफ प्रोडक्ट बी with time is nothing but rate of reaction. Okay, mathematically we can give rate of reaction in terms of the reactant as rate of reaction is equals to minus dA upon dt, and in terms of product it is given as plus dB upon dt. Okay, now see here negative sign is shown for reactant and the positive sign is shown for product. Now what happens if you see this graph? So if you plot a graph between concentration of A with time t, okay, what happens? The concentration of A is continuously decreasing. Okay, so if you plot a tangent to it, then what happens? The tangent goes down. Okay, so instantaneous rate tangent is going towards negative direction. Okay, or other words, the concentration of A is continuously decreasing. Say for example, initial concentration was say 10 moles, but say after 30 minutes the amount of reactant present is 2 mole. So if you calculate for 30 minutes, then it is final amount, that is 2 moles minus 10 mole divided by time 30. So 2 minus 10 is minus 8 by 30, so negative sign. Okay. Okay, so therefore rate of reaction in terms of the reactant is negative, but in terms of product is positive. Means say initially the concentration of product B is 0, but after some time 8 mole is produced, say after 30 minutes. What happens? The final amount 8 moles, initial amount 0 divided by 30. So 8 minus 0 is 8 divided by 30. So it is positive quantity. So rate of reaction in terms of the reactant is negative, and rate of reaction in terms of product is positive. Okay, if you see the same graph, if you plot the tangent to this in terms of product concentration, it is going towards positive direction. Okay, so either way, the rate of reaction is negative in terms of reactant and positive in terms of the product. Okay, now see here, negative sign is for, once again, the concentration of the reactant is continuously decreasing, and the positive sign here for as the concentration of the product is continuously increasing. Okay. Yes. Okay. Now see, now units of rate of reaction. So what are the units of rate of reaction? Now if you see, just a rate of reaction in terms of the say product, it is dV upon dt. So T is a time and B is the concentration of product B. Now concentration is expressed in units of moles per liter, and for time you can use any unit, say seconds, minutes, hours, days, and so on. Okay, therefore if you see this portion, so rate is equals to concentration divided by time. So dB here in concentration, dt in time. So concentration is given in moles per liter, time in second. So unit of rate of reactions are moles per liter per second. Okay, now instead if you're using, say, instead of second you are using minutes, then the units are moles per liter per minute. If you're using hour as a time unit, then it will be moles per liter per hour. Okay, so these are the unit of rate of reaction. Okay, see once again, so the branch of physical chemistry.
Excuse me, sir. Pathan, sir.
Yes. Yes, sir.
The board.
दिसत नाही का? Yes.
Your video is off, sir.
What happened?
Your video.
Yes. Is it okay now?
No, sir. Completely. Yeah, it's okay.
Okay.
Okay, sir.
See. So see once again. So concentration units are moles per liter, and that of time are second, minute, hour, etc. So rate of reaction is given as concentration divided by time. So concentration units are moles per liter, time, seconds. Therefore, ठीक है? Is it okay? Then now let us go for the most important point of chemical kinetics, that is known as rate law. ठीक है? एक the rate law समझ ला कि chemical kinetics quite easy. See, what is rate law? Now, it is found that experimentally it is found that the rate of reaction, rate of any reaction, rate of reaction is directly proportional to concentration. Rate of reaction is directly proportional to concentration of reactant. Okay. Okay. So this statement is nothing but Rate law. This is experimentally determined quantity. Okay. See once again, what is Rate law? The rate of reaction is directly proportional to concentration of the reactant. Okay. Being raised to some power. Being raised to some power. So underline this some power. Okay. किती power आहे exactly किती येईल हे आप सध्या तरी सांगता येत नाही. Okay, that will be determined after experimental study. Okay, so rate of reaction directly proportional to concentration of the reactant, and that concentration is raised to some power. Okay, for example, say your reaction is A gives B, then its rate is directly proportional to concentration of the A, that is reactant, and it is raised to some power, say N. Okay, so this N here is order of reaction. Okay, now this is proportionality sign. So if you remove this proportionality sign, if you remove this, okay, if you remove this proportionality sign, you are going to some constant, say K, and you can write this as rate is equals to K into A to the power N. So this K is known as rate constant. This K is known as rate constant, and this expression, mathematical expression, is nothing but rate law. Okay, what is rate law? So the rate of reaction is directly proportional to concentration of the reactant raised to some power. Okay, now it is not saying it is 1, 2, 3, 4 or so. Okay, it is raised to some power, and that quantity which is unknown can be, yes. So this quantity which is raised to some power is unknown quantity. Okay, that can be only determined by using experimental procedures. You cannot find it by using simple balanced chemical reaction. Okay, so this mathematical statement is nothing but rate law. Okay, see once again, this K is rate constant. This N latter you will find it is order of reaction, A is concentration of the reactant. Okay, let us see, for example, you have a reaction, say 2A gives 2A plus B gives product. Now rate of this reaction is given as, say, rate is equals to K into concentration of A to the power M and into concentration of B to the power N. Okay, so A to the power M into B to the power N. Okay, this statement, this mathematical equation is called as rate law. Now if you see this example, in this you are using 2 moles of A and 1 mole of B. Okay, here you have 2 mole of A and 1 mole of B. We don't write 1 generally. Okay, so number of moles of reactant A are 2 and that of B are 1. No, just 1. Okay, now what happens here? This M is not equals to 2, or here N is not equals to 1. Okay, M and N will be determined experimentally. You cannot find out it. Okay, so you can just find out by using this balanced chemical reaction, but you have to find it by using experimental method. After doing experiment, you can find out the value of M and N. Okay, here K is rate constant, M and N are powers. Okay, raised to powers are raised to the concentration terms of the reactants. Okay, so this equation is known as rate law. Okay, so here order of reaction is equals to M plus N. We'll let us study in detail order of reaction. Okay, K is rate constant. Okay, for example, the reaction of decomposition of N2O5. Now see, so N2O5, two molecules react, decompose to form 4 NO2 and 1 oxygen. Now the rate of this reaction is found to be rate is equals to K into concentration of N2O5 raised to 1. Okay, this is experimentally determined quantity, and it is found that the rate of reaction for the decomposition of N2O5 is directly proportional to concentration of N2O5 raised to power 1, though you are using 2 molecules of N2O5. But in rate law, it is shown that only one power is given. Okay, so this is rate law for the decomposition of the reaction. Okay. Now let us give a second example. Say the reaction between H2 and I2. Now H2 I2 react to form 2HI. Okay. Now rate of reaction for this reaction is rate law is equals to rate is equals to K into concentration of H2 into concentration of I2. Okay, here hydrogen raised to power 1, iodine also raised to power 1. Now rate of reaction now depend upon both the concentration of hydrogen as well as concentration of iodine. Okay, so these statements are nothing but rate law. Okay, remember once again, by looking at the balanced chemical reaction, you cannot write rate law. Rate law is a experimentally determined quantity. Okay, after doing experiments, you can find out rate law. Otherwise, you cannot state it. Okay, so let us go for the next point, that factors affecting rate of reaction. Factors affecting rate of reaction. Okay. Factors affecting rate of reaction. See, now say A plus B gives C plus D. Now you have A and B as reactants and C and D are products. Now what happens? If you increase the concentration of A and B, the rate of reaction increases. If you decrease the concentration of A and B, the rate of reaction decreases. So the first factor that affect rate of
Hello.
reaction is
Hello.
concentration.
Sir, your
Yes.
video is off.
Yes.
Pathan sir.
Yes, yes. एक second, sir.
Yes. Yes, sir. Now it is on.
एक second, sir. Yes. Okay. Now is it? एक फोन आला होता सर.
Okay, sir.
Okay. See, various factors that affect rate of reaction. So the first factor, okay, is it visible?
Yes,
First
sir.
factor is concentration. See, now, so the rate of reaction is directly proportional to concentration. We have seen rate law. Now, in the case of rate law, the rate of reaction is directly proportional to concentration. So the first factor that affect rate of reaction is concentration for all reaction except zero order reaction. If you leave zero order reaction, remaining all reactions, the rate of reaction is directly proportional to concentration. Okay. Now rate of reaction increases as the concentration increases, and the rate of reaction decreases as the concentration decreases. Okay. So when concentration of A and B are very high, the rate of reaction is very fast. So initially rate of reaction is fast, but as the concentration of A and B decreases, the rate of reaction also decreases. Okay. Sometimes what happens, the product form that affect rate of reaction. Okay, so the formed product act as a catalyst. Now if that product is enhancing rate of reaction, the product form is acting as a catalyst and it is increasing rate of reaction, then what happens, as the amount of product increases, rate of reaction also increases. But sometimes what happens, this product act as a negative catalyst. Okay, act as an inhibitor, and thus as the amount of product is formed, it stops the reaction, it reduces rate of reaction. So depending upon the situation, whether your product is acting as a catalyst or not, in general the rate of reaction now depend upon concentration. Higher the concentration, higher the rate; lower the concentration, lower the rate of reaction. Okay, thus rate of reaction is directly proportional to concentration of the reactant. Okay. Now second point, temperature. Another factor that affect rate of reaction is temperature. Now we know that as the temperature increases, the molecular energies also increases. Okay, for example, if you have a gas, so the temperature increases, the average kinetic energy of the gas molecules also increases. Okay, if you have a liquid sample, temperature increases, velocity of molecules also increases. Now rate of reaction therefore depend upon temperature. Now say A plus B gives AD. Now A collide with B, then B collide with A. A and B collide with each other and they form product, say AB. If the collision is increases, the chances of formation of the product also increases. So the kinetic energy of the A and B increases with the increase in temperature. Overall average energy threshold energy of the reactants also increases with the increase of temperature. Thus finally the temperature increases, rate of reaction increases. Now it is observed that it is if there is a 10 degree centigrade increase in the temperature, then the rate of reaction increases by 2 times or twofold or 3 times. Okay, so that can be given as in terms of temperature coefficient. That is given as temperature coefficient. Here we take ratio of the rate constants. Okay, so rate constant at a higher temperature divided by rate constant at lower temperature, their ratio, they are equals to 2 or 3 sometimes. Okay, so what happens in general, if the temperature of the reaction increases by 10 degrees centigrade, the rate of reaction doubles or triples. In brief, Temperature increases, rate of reaction increases, because average kinetic energy of the molecule also increases, or minimum energy required to do reaction or threshold energy increases, thus rate of reaction increases. Okay. Third point, that is called as pressure. Okay. Now, pressure is just like concentration. Okay, when using gas samples. Okay, if the reactants are gas, then instead of concentration we say pressure. So pressure is nothing but concentration for gas sample. So as the concentration increases, that means as the pressure increases, the rate of reaction of gaseous samples also increases. So increase in the pressure increases the rate of reaction. Okay, so आपण 3 पॉइंट बघितले. काय काय बघितलं? See first the concentration, then temperature, then pressure. So as the concentration increases, rate of reaction increases. Temperature increases, rate of reaction increases. If there is increase in the 10 degree centigrade of temperature, the reaction doubles or triples. Rate of reaction दुप्पट होते कि 3 टाइम बढ़ते हैं, 3 times increase होते. Okay, in the same way with pressure, the pressure increases, the rate of reaction also increases, because for gaseous sample the concentration of the gaseous samples is expressed in terms of pressure. Means high pressure means high concentration of the gas, low pressure means low pressure of the gaseous samples. So pressure increases, rate of reaction also increases. Okay, so fourth point, that is effect of solvent. Effect of solvent. Okay, now solvent, you can use benzene, you can use ether, you can use alcohol, okay, etc. for the say chemical reaction. Okay, now if you see, some solvents are polar in nature and some solvents are non-polar. Okay, like say benzene. Okay, benzene is a non-polar, ether is a non-polar, then ethanol, methanol, okay, chloroform, they are polar in nature. Okay, now effect of solvent on rate of reaction. Okay, this is in brief, very short term. Say a product is B from reactant A. If B is polar, okay, if the product B is polar and solvent is polar, both are polar, product form is polar, solvent is also polar, rate of reaction increases. Okay, and if the product is polar and solvent is non-polar, it does not help in increasing the rate of reaction. Okay, or rate of reaction may decrease. Okay, this is very short term. Effect of solvent, you have to check whether that solvent is polar or non-polar. Okay, then check the product, whether product B is say polar or non-polar. If product is polar, solvent is polar, rate of reaction increases. If product is non-polar, solvent is non-polar, rate of reaction increases. But if in reverse, the product is polar, solvent is non-polar, rate of reaction decreases. And product is non-polar, but solvent is polar, rate of reaction again decreases. So like dissolves like. Okay, like dissolves like. That means for polar, polar helps, for non-polar, non-polar help. Okay, so this is effect of solvent. Okay, and next, any problem till yet? Anyone? Is it visible?
Yes, sir.
Okay, let us go for the next point, that is catalyst, presence of catalyst or use of catalyst in the or effect of catalyst on rate of reaction. So okay, so effect of catalyst on rate of reaction. Obviously, now if you have catalyst either negative or positive. Let us say positive catalyst or the catalyst which increase rate of reaction. So if you are using catalyst, rate of reaction increases. Okay, so by the presence of catalyst, the rate of reaction increases. Reason why? So if you are using catalyst, then catalyst जो है तो it provides alternate pathway for the reaction, which is having lower energy of activation. Okay, for example, so this is a activation curve of some reaction. Okay, say A gives B. So this much amount of energy is required to what happened?
Hello, sir. Pathan, sir. Hello. Hello. Pathan, sir.
Hello.
Yes, sir. Yes.
Yes. What happened? Can you see? Sir.
Yes,
So
sir.
that was the effect of catalyst. So if you are using catalyst, now what happens? Catalyst provide alternate pathway, and that lower energy of activation. For example, if you are not using any catalyst for the reaction, and the energy profile is just like this, so it should pass this transition state to reach to product B. Okay, now if you're using catalyst, what happens? Catalyst provide alternate pathway. Energy of activation decreases to the minimum. Okay, so if you compare these two, okay, so this is 1, this is 2, this is without catalyst, using this catalyst. So if you see second pathway, the energy of activation for another pathway which was provided by the catalyst is having low energy of activation. But if you're not using any catalyst, then here energy of activation is quite high. Okay, so rate of reaction when energy of activation is higher is lower, but if you're using catalyst, the rate of reaction is quite fast. Okay, so you're using catalyst, rate of reaction increases. Okay, so these are all the factors that affect rate of reaction. Okay, so first factor was concentration. The rate of reaction increases with increase in concentration. Okay, rate of reaction increases with increase of temperature. In case of gaseous samples, pressure is just behaving like concentration. So higher the pressure, higher the rate of reaction, lower the pressure, lower the rate of reaction. The next was solvent. If you are using polar solvent and product is also polar, rate of reaction increases. And if you are using non-polar solvent, product is also non-polar, then rate of reaction again increases. So like dissolves like in that way. But if you have polar solvent and non-polar product, rate of reaction decreases in the vice versa. Okay, let us go for the next point. Okay, last, that was catalyst. So if you are using catalyst, the rate of reaction increases with the use of catalyst. Okay, let us go for the next point, that is molecularity of the reaction. Molecularity of the reaction. This is very simple. Okay, see, it is very simple. Number of molecules, number of reactant molecules taking part in a chemical reaction is nothing but molecularity. For example, this, say A gives B. How many reactants are used? Only one. Therefore, it is unimolecular reaction. Okay. Now, second, A plus B gives C. A plus A give B. Here, we are using two reactants. Okay. हे दोन्ही सिमिलर आहेत, एक सारखे आहेत, परंतु दोन लागतात. So molecularity of such reactions is 2. Okay, bimolecular. In this case, it is 1. Now, if you are using, say, this A plus B plus C gives D. Here, you are using 1, 2, 3, 3 molecules as a reactant. So the molecularity of the reaction is 3 in this case. Okay, so the number of reactant species, the number of reacting molecules, number of reactants molecules involved in a chemical reaction taking place in a reaction. So that number is simple, known as molecularity of the reaction. So if it is just 1, then the reaction is called as unimolecular. Okay, if you are using 2 reactant molecules, then that is known as bimolecular reaction, and for 3, then that is known as trimolecular reaction. Okay, now in case of unimolecular reaction, okay, for example, bromine decomposes to form bromine atoms. This is unimolecular reaction. Okay, or simply malic acid. This is the structure of malic acid. A malic acid converted to fumaric acid. Okay, and have double bond jo rotate होऊन जातो. Okay, and what happens? HC. Okay, हे anti होऊन जातं COH group. Okay, so this is fumaric acid, and this one is malic acid. So these two examples are of unimolecular reactions. Okay. Then bimolecular reaction. So A plus B gives product. This is bimolecular reaction. Now what happens? So when we study hydrolysis of ethyl acetate, okay. So this is CH3COOH. This is acetic acid. Remove OH. Okay. Then connect C2H5. This is ethoxy part. So this is ethyl acetate. So hydrolysis of ethyl acetate, okay, in presence of acid or base, gives CH3COOH plus C2H5OH, that is ethanol. So here 2 molecules are used. The reaction is bimolecular in nature. So molecularity of the reaction is 2. Okay, see once again. So this is ethyl acetate, hydrolysis process H2, reaction with H2 with the formation of acetic acid and ethanol. Number of molecules used are just 2. Molecularity of the reaction is 2. Okay, then next, now A plus B plus C, 3 molecules are used for the reaction. Okay, for example, it is NO 2 times plus Cl2 with the formation of 2 NOCl, or 2 NO plus O2 with the formation of 2 NO2. Here 2 NO molecules, 1 used. See 2 NO, 1 chlorine, total 2 plus 1, 3. 3 molecules are used. Okay, so number of reacting species are 3. Therefore, molecularity of this reaction is 3. Okay, so we have studied in brief unimolecular reaction, bimolecular reaction, and trimolecular reaction. Okay, let us go for the next point, that is called as order of reaction. Order of reaction. Okay, see, order of reaction is can be obtained from rate law. Okay, say you have reaction A plus B gives say product, and you found out its rate law as rate is equals to K into A to the power M into B to the power N. Okay, so this is rate law for this reaction, A plus B give product. Okay, now what happens here? This power term in this rate equation, okay, this power term M and power term N, the summation of these power terms are nothing but order of reaction. Okay, order of reaction is defined as the sum and a total summation to sum of powers of concentration terms in rate law. So A and B in the square bracket. Square bracket means moles per liter. So A and B are concentration terms and their powers are M and N. So the summation of M plus N. Okay, so summation of M and N is nothing but order of reaction. Okay, so order of this reaction is order is equals to M plus N. Now you can also define order in terms of either A or either B. Okay, the order of reaction can be explained in terms of A or B. Now see here, now in this rate law, A is given power M. So order of reaction with respect to A is M and B is given power N. So order of reaction with respect to B is N. Okay, so overall order is M plus n, and order with respect to A is, if you see a to the power m, it is m, and order of reaction with respect to B, if you see this e to the power n, that is n. Okay, so order of reaction. Okay, see one second definition. Order of reaction is nothing but summation of powers of concentration terms in rate law. That means you have to first find out rate law experimentally, है ना, experiment करून, performing experiment, you will find rate law. Then in that rate law you have to see concentration terms and their powers, and then add or sum, है ना, take some of those powers, that will give you order of reaction. Okay, so if that m plus n is equals to 0, then that reaction is known as zero order reaction. If it is 1, then that is known as first order reaction. It is 2, then that is known as second order reaction. And if it is 3, then that is known as third order reaction. Okay? That is order of reaction. The order of reaction is defined as the sum of powers of concentration terms in rate law. This is rate law. These are concentration terms. These are the powers. The sum of powers is nothing but order of reaction. If it is 0, 0 yete. Okay, fraction मध्ये सुद्धा येते. Okay, it may be 0 in fraction or whole number. Okay, so if it is 0, then that reaction is zero order reaction. If it is 1, m plus 1, n plus n is equals to 1, then it is first order reaction, then second order reaction, third order reaction, and okay. Another thing I want to show is say A plus B plus C gives product. Now you are doing some experiment. Now you are increasing, say you are taking these 3 reactants and they are giving product. Now what happens? You are studying it, you are performing experiment. Now you are focusing on A. Okay. Now you are increasing concentration of A. As the concentration of A increases, rate of reaction also increases. Concentration of B decreases, rate of reaction decreases. Okay. Then you have focused your attention towards B. Now what you did, the concentration of B is increased. There is no effect on the rate of reaction, or the concentration of B is decreased. Okay, concentration of B is decreased. Again, there is no effect on rate of reaction. Then the concentration of C. Okay, you have focused on concentration of C. Okay, now what happened? So as the concentration of C is increased, the rate of reaction does not change, or concentration of C is increased, again the rate of reaction does not change. So either you increase or decrease concentration of B and C, there is no effect of the rate of reaction. But by the change in concentration of A, rate of reaction increases or decreases. That means only one, okay, this is only one reactant concentration is affecting rate of reaction. Therefore, as only one reactant concentration is affecting rate of reaction, then this is first order reaction. Okay. Now another case, if the concentration of A and B both are affecting rate of reaction. Remember, if you have 3 different reactants, but in case of first order reaction, only one reactant is affecting rate of reaction. Another 2 are present, they are necessary. You have to hello. Okay, see. So if only concentration of A and B, okay, concentration of A and B are affecting rate of reaction, the concentration of C does not alter rate of reaction. That means 2 reactant concentrations are affecting rate of reaction, then that is known as second order reaction. And last, all three, okay, all three, they are taking part, they are affecting rate of reaction, then that reaction is known as third order reaction. Okay. And if the concentration of A, concentration of B, concentration of C, all these three are not, they are not affecting rate of reaction. You increase concentration of A or B or C, or you decrease concentration of A, B, C, nothing. Rate of reaction is constant overall. There is no change in concentration. There is no change in rate of reaction after changing concentration of any. That means it is zero order reaction. Okay, so that was order of reaction. Okay, standard definition kai, order of reaction is defined as sum of powers of concentration terms in rate law. So first find rate law and look at rate law, then find out order of reaction. But to get molecularity of the reaction, just write balanced chemical equation and you will get number of reactant molecules. You can easily say molecularity of the reaction. Remember, molecularity is not experimentally determined quantity, but order is experimentally determined quantity. Okay, let us go for the next point, that is zero order reaction. Okay, now what we do in case of zero order reaction, we'll find its integrated rate expression. Okay, so let us go for the point zero order reaction. Okay, zero order reaction. Remember here order is zero. That means the concentration of any reactant is not affecting rate of reaction. Okay, see, as per name, zero order reaction, rate does not depend upon concentration of any reactant. Okay, rate is independent of the concentration of the reactant. Therefore, let us consider a reaction, say A gives product. Okay, now A gives say product. Okay, now initial concentration of A is small a, that of product is 0. Okay, now what happens? A react with each other with the formation of the product. With time, concentration of A continuously decreases and that of product is increases. Say at some time, okay, at any some time t, the remaining, okay, the remaining concentration of A is A minus X and that of product is say X. इथे जो आहे केमिकल कायनेटिक्स मध्ये हे हा जो आहे A minus X सिंगल टर्म आहे. Okay, this is remaining concentration of this capital A after some time t. म्हणजे सुरुवातीला तुम्ही हा जो A आहे तुम्ही 10 मोल घेतला असेल किंवा 20 मोल घेतला असेल. Okay, so say you have taken 20 mole after some time. Okay, what happens? A react to form product, then the remaining amount of the reactant A is 8 moles. So this 8 is A minus X and initial is A. Okay, so the remaining concentration of reactant A after some time t is A minus X and initial concentration, that means when time was 0, reactant as it is आहे जसे तसा जेवढा घेतला होता तेवढाच and the product is 0. Okay, now the rate of reaction for this is, now rate of reaction in terms of product is equals to dx upon dt. Okay, the rate of reaction in terms of product is dx upon dt, and as it is a zero order reaction, dx upon dt is directly proportional to concentration of A raised to power 0 at some time t. ठीक आहे. आता 0 कशामुळे घेतला? I have taken 0 as power because it is a zero order reaction. Okay. Therefore, dx upon dt is equals to, at some time t, concentration of A is A minus x. So A minus x to the power 0. Remove this proportionality sign, introduce some constant. So dx upon dt is equals to k0 into A minus x to the power 0. Anything to the power 0, x to the power 0 or a to the power 0 or b to the power 0, anything to the power 0 is equals to how much? 1. Okay, so A minus x to the power 0 will be equals to 1. That means dx upon dt is equals to k0 into 1. Now, therefore, now we want its integrated rate expression. This is derivative form. So to get integration, we must separate variables and then integrate. Okay, so therefore, separating variables. Okay, so dx एका साइडला आणि k0 dt दुसऱ्या साइडला. Okay, so we have separated those variables. Now, एकदा separation झाला की आता integration करा. So on integrating, we get what happens after integration. So dx is equals to x, k0 is constant as it is, and dt will be equals to t. Okay, now let's see. Here in this expression, so it is infinite integration. Okay, we have separated these variables and then we did integration. Okay, and in this integration we don't have any limits, so that was infinite integration. For infinite integration we introduce some constant c. Okay, so this c is integration constant. What is this? C is integration constant. Okay, now we have to find the value of c, then put this value into this equation, then you will get the value of k0. Okay, that will be our last step. Okay, so say it as equation number 1. Now always remember, in future, for zero order, first order, second order, and third order reaction, all, if you want to find out integration constant, just check initial conditions. So what was the situation when t was 0? Put those initial conditions and find the value of c. Okay, therefore, to find value of c, put initial condition that at t is equals to 0. So when t was 0, x was 0. X was also 0. Therefore, here x is equals to 0. इथे x ऐवजी 0 होईल, k0 as it is t 0 plus c. Okay, so finally c is equals to how much? K into 0, 0. So 0 is equals to 0 plus c. That means c is equals to how much? 0. Say it as equation number 2. Put this value of c from equation number 2 to equation number 1. Therefore, from equation number 1 and 2, we get x is equals to k0 t plus c means 0. Okay, so forget this 0. It is x is equals to k0 t, or k0 is equals to x by t. So this is the last expression. Okay, Here K0 is rate constant for zero order reaction. 3 is integral. Okay, see, K0 is rate constant for the zero order reaction, and this equation number 3 is nothing but rate expression, integrated rate expression for zero order reaction. Okay, पुन्हा एकदा बघा derivation of zero order reaction. ठीक है. So A give product at time is equals to 0. Concentration of A was small and that of product is 0. Current reaction सुरुच नाही झाली. So when reaction proceeds, A react to form product and the concentration of A continuously decreases. At some time t, remaining concentration of A is A minus X high A and the product is X. Now, as we said, it is zero order reaction. Therefore, rate of reaction in terms of the product dx upon dt is directly proportional to A to the power 0. Now put the value of A as A minus X, 0 as it is, R0 निघून जाईल. Okay, so first we have removed this proportionality sign and introduced K0. Okay, now A minus X to the power 0 is 1. Therefore, dx upon dt is equals to K0. Then separate it, separating variables. So dx is equals to K0 dt. Then on integration or on integrating this is infinite integration. There is no limit. Therefore, we get x is equals to K0 t plus c. There, this t is time and c is integration constant. Always remember for zero order, first order, second order, third order, all. You want to find constant value of constant, put initial condition. So when t is equals to 0, x is equals to 0. So we have used those values. Instead of x, put 0, K0 as it is, and instead of t, put 0 plus c. So implies c is equals to 0. Put this value into that equation number 1. Then we get x is equals to K0 t or K0 is equals to x by t. This is last expression, say equation 3. Okay. So equation number 3 represents integrated rate expression for zero order reaction. Okay. Let us go for the characteristics. So I will tell you simple 2 characteristics. Okay. See, always remember first characteristic is unit of rate constant. Okay. For all reactions. That means for first order, second order, third order, zero order, all. First characteristic is unit of K0 or unit of K, which is rate constant. Now here, if you see K0 is equals to x by t, x is concentration divided by time. Now concentration is given in moles per liter and t is in seconds. So unit of rate constant for zero order reaction is moles per liter per second. So this is characteristic number 1. Okay. So first characteristic is unit of K0. Okay. Now, if you see second characteristic. Now, as it is a zero order reaction, okay. Now, if you plot a graph between rate of reaction, okay, and time. If you plot rate of reaction with time, you will find a straight line. Okay. Now, there is no change in the rate of reaction. You can count it as a second characteristic. Then, third characteristics is half life. Half life order. Okay. So characteristic, say number 3 is half-life of zero order reaction. Now, what is half-life? Okay, so the time required to complete 50% of reaction or to reduce initial concentration to 50%. Okay, so the time required to reduce initial concentration of the reactant to 50%, that much time is known as half-life of the reaction. For example, you have taken 2 mole of initial reactant. Now, conversion of 2 mole to 1 mole, that means 2 mole was initial reactant that was starting reaction, and remaining reactant after some time T is 1 mole, that means 50% of initial, then that T is nothing but half-life of the reaction. Okay, so it is the time required for the half of the reactant to change into product. Okay, it is denoted as, see, T half. It is the time required for half of the reactant to change into the product, or it is the time required to reduce 50% of the initial reactant to product. Okay, so T half is half-life of the reaction. Okay, the initial concentrations are ASL, तर याचा अर्ध म्हणजे A/2. Conversion A to A/2, the time required is known as half-life of the reaction. Okay, therefore, so we have zero order rate expression as K0 is equals to X by T. Ata, if you are using T as T half, then K0 is equals to T च्या ऐवजी T half आणि X च्या ऐवजी initial concentration चा अर्धा A/2. Okay, therefore, now T half, or you can also write as a T 0.5 is equals to 1 upon K0 into A/2. Okay, 1 upon K0 into A/2, or 1 upon 2 times K0 into A. ठीक है 1 upon 2 constant, K0 constant, so 1 upon 2 gives 1 upon 2 into K0 is also constant. So T half proportional to A. That means the half-life of the zero order reaction is directly proportional to initial concentration A of the zero order reaction. Okay? So these are characteristics of zero order reaction. Very characteristic, unit of K. दूसरी concentration. Okay. आणि तिसरी half-life of the reaction. Okay. Examples. Examples of zero order reaction. Okay, the first example is bromination of acetone. Okay, so acetone reacts with the bromine with the formation of bromine substituted acetone. Okay, so this reaction follows zero order rate law. That means rate of reaction does not depend upon concentration of the acetone or concentration of bromine. Okay, so this is one of the example of zero order reaction. Another example is the decomposition of PH3. Okay, it forms 2P plus 3H2. Okay. Yes. Okay. So decomposition of phosphine. Is one of the example of zero order. Let's go for the first order reaction. Integrated rate expression for first order reaction. Okay. First order reaction. See. Now last time जसं आपण zero order reaction साठी जसं आपण expression discuss केला, in the same manner we'll derive rate expression, integrated rate expression for first order reaction. Okay. See. So let us consider a reaction. A gives product. Okay. Usual method is same process, everything will be same. Okay. Now, at initial condition, when time was 0, the concentration of A is small a, that of product is 0. This is initial situation. At some time t, okay, when reaction proceeds, A form product and the concentration of A decreases. The remaining concentration of A after some time t is A minus X, and the product concentration is X after some time t. Okay. Then, as it is a first order reaction, a rate of reaction is dependent upon concentration of only one reactant, or in case of rate law, concentration is raised to power 1. Therefore, the rate of reaction in terms of the product is dx upon dt is equals to, say, rate constant as k1 A minus X to the power 1. Power 1 कशामुळे दिला? Because it is a first order reaction. Okay, त्याला मी असं सुद्धा लिहू शकतो बघा, dx upon dt directly proportional to concentration of A to the power 1. Instead of concentration A, you can write A minus X to the power 1. Then remove this proportionality sign and introduce constant K. So remove it. So for first order reaction, we are using K1. Last time that was 0, so we used K0 as a term. So K1 into A minus X to the power 1. It is not necessary to write that one. Okay. So as usual, separating variables. ठीक है. So it is equation number 1. The x चे टर्म जिथे जिथे ते सेपरेट करा, t चे टर्म एका साइडला, इथे a minus x, x चे टर्म इकडे जाईल, t इकडे येईल. So dx upon a minus x is equals to k1 dt. These are a separation of variables. Say it as equation number 2. Then on integrating equation number 2, we get, so on integration, we get integration of dx upon a minus x is equals to integration of k1 integration of dt. आता हे k1 कॉन्स्टंट म्हणून इंटिग्रेशनच्या बाहेर काढलं मी. ओके. नाउ आता 1 upon x dx चा इंटिग्रेशन येतो log of x. ओके. Therefore इथे सेम आहे, 1 upon a minus x dx याचे सुद्धा इंटिग्रेशन येईल log of a minus x. ठीक है, it will be log of a minus x, but this x having negative sign, so it will be minus log of a minus x is equals to k1 as it is dt child t. Now this is infinite integration, so we have to introduce some constant, say c. This c is integration constant. Okay, what is this? C is integration constant. ठीक है. Then say it as equation number 3. काय केलं आपण? First order reaction है, A gives product, initial condition T is equals to 0, A आहे, concentration A चा, product 9. Now after some time T reaction will proceed, product will be formed, a concentration of A will decrease, remaining concentration of A, उरलेला amount. So remaining concentration of reactant A after some time T is A minus X. Okay, and that product will be X. Now as it is a first order reaction, you can write differential rate expression as dx upon dt is equals to k1 into A minus X. Okay, then after separating variables, you get dx upon A minus X is equals to k1 dt. Integrate it, you reach up to this minus log of A minus X is equals to k1 t plus c. Now this, to find the value of this c, okay, to find the value of c, you put initial condition. Okay, the initial condition काय आहे? At t is equals to 0, x is equals to 0. Therefore, okay, put t is equals to 0 and x is equals to 0. Okay, therefore it's a minus log of as it is, a as it is minus 0, x ची 0 is equals to k1 t ची पुन्हा 0 plus c. Okay, k1 into 0 0 होऊन जाईल, a minus 0 म्हणजे a, it will be minus log of a. So therefore, okay, that implies value of c is equals to minus log of a. Okay, now you got the value of c as minus log of a. Say it as equation number 4. Okay, now this is equation number 3 and this one is equation number 4. Put that value of c from equation number 4 into equation number 3. So carefully write this equation as minus log of a minus x is equals to k1t at the plus c चाहिए minus log of a. ठीक है, ये log term से का साइड लग गया. Remember, this is natural log. It is not log to the base 10, but it is a natural log. Okay, minus log of a इकडे गेला तर plus होईल. It is log of a minus log of a minus x is equals to k1t, or simply merge करून टाका, log of a divided by a minus x is equals to k1t, or k1 is equals to 1 upon t. t इकडे आणला. Okay, it will be k1 is equals to 1 upon t into log of a divided by a minus x, and this is, say, equation number 5 is nothing but integrated rate expression for first order reaction. This is integrated rate expression for first order reaction. Okay, now this is natural log converted to log to the base 10. So to convert this log to the base 10, we multiplied by 2.303. Therefore, what happens? K1 is equals to, it is 2.303 divided by t into log of a divided by a minus x. Okay, so it as equation number 6. So this equation number 6 is nothing but last equation, that is integrated rate expression for first order reaction. Okay, this is integrated rate expression for first order reaction. Next point, characteristics. Any problem in this? This take सर्वांना properly? Yes. Okay. So characteristics, as usual last time जसं आपण घेतला दोन characteristic घेऊ. पहिली characteristic unit of this K, दुसरी characteristic half life of the reaction. ठीक है, unit of K and half life of the reaction. See, so characteristic number 1, that is unit of K1. ठीक है. See, आता हा expression बघा, K1 is equals to 2.303 divided by T into log of A divided by A minus 6. The 2.303 unit 9 time T, हे concentration, हे सुद्धा concentration. तर K1 will be equals to 1 upon time into, हे log सोडला तर हे A म्हणजे concentration, A minus x पुन्हा concentration is concentration, A minus x concentration. So unit of K साठी K1 is equals to 1 upon time into concentration divided by concentration. हे दोन्ही कॅन्सल, काय होईल फक्त 1 upon time. आता टाइमची युनिट तुम्ही काय घेऊ शकता, सेकंड्स घेऊ शकतात, मिनिट घेऊ शकतात, आवर्स घेऊ शकतात, मंथ, डेज एंड ऑल. ओके, सो first characteristic is unit of K is per second किंवा per minute किंवा per hour and so. So per unit time is the characteristic number 1 for the first order reaction. ठीक है. Let us go for the second characteristics, that is half life of the first order reaction. Again, what is half life? So half life of the reaction is the amount of time, the total time required to half the initial concentration. Okay, म्हणजे initial concentration चा अर्धा संपून टाकण्यासाठी जो time लागेल, that is known as half life of the reaction. Okay, now see here initial concentration was A, त्याचा अर्धा म्हणजेच A by 2 half होण्यासाठी जो time लागेल, that is known as half life of the reaction. Okay, so we'll put here instead of T half, instead of A we'll put A minus X. Okay, sorry, instead of A we'll put A half. Okay, see half life of the first order reaction. See, so it is K1 is equals to 2.303 divided by T into log of A divided by A minus X. ठीक है, it is 2.303 divided by T च्या T half. ठीक है, log as it is, A as it is, पुन्हा A as it is, X च्या म्हणजे अर्धा. A by 2. ठीक है, तो अर्धा गेला की अर्धा उरतो, A minus A by 2 is equals to A by 2. Therefore it is 2.303 divided by T half into log of A divided by A by 2. A cancel, A yield 2.303 divided by T half into log of 1 divided by 1 by 2. The 1 divided by 1 by 2 means 2. So 2.303 divided by T half into log of 2. आता log of 2 ची व्हॅल्यू किती असते, log to the base 10 आहे, it is 0.3010. कुठे it is 2.303 into 0.3010 divided by T half. Okay, so if you multiply 2.303 into 0.3010, it is equals to 0.693 divided by T half, or simply T half is equals to 0.693 divided by K1. Okay, so on the basis of this equation, we have numericals. Okay, so T half is equals to 0.693 divided by K1. Now, if you see this last point, this equation does not have initial concentration term A. है ना? T half is equals to 0.693 divided by K1. Half life है आणि rate constant है. A ची value, A ची term नाहीच. That means half life of first order reaction. Okay, so half life of this first order reaction does not depend upon initial concentration. Okay, of initial concentration. Okay, so that was second characteristic. Examples of first order reaction. Okay, now see, first example is inversion of cane sugar. Inversion of cane sugar. Now see, what is the reaction? So cane sugar is sucrose, C12H22O11. याचा hydrolysis होतो in presence of say acid HCl/H2SO4. Okay, so hydrolysis of sucrose in presence of acid, it forms C6H12O6 plus C6H12O6. एक है ग्लूकोज, दूसरा है फ्रुक्टोज. ठीक है. नाउ याचे जर प्लेन पोलराइज्ड लाईट मध्ये पोलॅरोमीटर मध्ये रोटेशन बघितलं तर 90 डिग्री. ओके, आणि ग्लुकोजचा आहे 52.5 आणि फ्रुक्टोजचा आहे -92. Okay, so what happens initially? The rotation of the sucrose is towards right hand side. Okay, it is dextrorotatory, but as the reaction proceeds and it forms glucose and fructose, the dextrorotatory mixture after completion of the reaction or at the end of reaction becomes levorotatory. Okay, so that was inversion takes place for the rotation. So this process, this reaction is known as inversion of cane sugar. Okay. Then hydrolysis of methyl acetate. Okay, so hydrolysis of methyl acetate in presence of acid. Okay, it forms CH3COOH plus CH3OH in presence of acid. So this reaction in which hydrolysis process takes place, this reaction also follows first order rate expression. Therefore, these are two examples of first order reaction. Okay, any problem till yet? Yes.
Hello.
Do students have any query?
No.
If you have any
Okay.
questions, so please.
Okay, we'll proceed to the
ask.
second order reaction. Okay, time आहे ना सर अजून?
होय सर, आहे कंटिन्यू करा.
So that एक सेकंड ऑर्डर रिएक्शन हे कंप्लीट करतो एक पार्ट, उरला पार्ट म्हणजे दुसऱ्या सेशन मध्ये घेऊ.
चालेल सर, चालेल.
Okay, thank you. So second order reaction. Okay, second order rate expression. Now see, A plus B gives product and A plus A also can give product. तर इथे ए आणि बी दाखवण्याचा उद्देश कसा की कॉन्सन्ट्रेशन ऑफ A and B are different. Okay, and in case of this second example, the concentration of both the reactants are same. Okay, to give reaction. Okay, I'm not saying those reactants are same, but their concentration are different. Reaction A आणि A दोन्ही reactant same सुद्धा असू शकतात, परंतु त्यांचे concentration same आहेत. ओके, आणि A प्लस बी सांगण्याचा उद्देश कसा की त्यांचे कॉन्सन्ट्रेशन वेगवेगळे आहेत. ओके, ठीक है. जैसे कि फॉर एग्जांपल हाइड्रोलिसिस ऑफ इथाइल एसीटेट CH3COO C2H5. This is ethyl acetate in presence of sodium hydroxide. It forms sodium acetate and ethanol. Okay, so if you do a hydrolysis saponification process, है ना, saponification means hydrolysis of ester base. So for a saponification reaction, it follows second order rate expression. Now what happens? इथे दोन प्रकार येतात, मोडतात, टू टाइप्स. एक, या दोघांचं कॉन्सन्ट्रेशन सेम घेतला, म्हणजे हे सुद्धा 0.1 मोलार, हे सुद्धा 0.1 मोलार, दोन्ही 0.1 घेतले तर सेम कॉन्सन्ट्रेशन, किंवा याचा 0.2 घेतला मोलार आणि याचा 0.1 घेतला तर हे वेगवेगळे कॉन्सन्ट्रेशन. The second order rate expression can be derived in two ways. If the concentration of the initial reactants are same, type number 1, and concentration of the reactants are different, that will be type number 2. Okay. एक सेकंड सर. Okay, are you getting all this?
Yes, sir. Yes, sir.
जो आहे ते सांगण्याचा उद्देश, the reactants are same or different? No, इथे दोन वेगवेगळे रिएक्टंट आहेत, but their concentrations are same. Type number 1. If the concentration taken initially are different, then type number 2. म्हणून इथे दाखवताना कसं आपण A plus A gives product, so that their concentrations are same, and A plus B give product, we are saying concentration are different. Okay, so second order reaction is derived in two ways. It's a derivation when concentration of both reactants are same, and second type, the rate. Okay, so first rate expression when concentration of both reactants are equal. Okay, so rate expression when concentration of both reactants are same or equal. Okay, then second type will be rate expression when concentration of both reactants are different. Okay, see, for example, now see it's a derivation. Now it is A plus A gives product. It is a second order reaction. A plus A give product असेल या किंवा 2A give product असं सुद्धा लिहू शकतो, no problem with that. Okay, so A plus A give product or 2A gives product. Okay. Now, initially when T was 0, initial concentration of A is small a and that of product is 0. After some time T reaction proceeds, it form product, the initial concentration decreases. So at some time T is equals to T. Okay. What happens? The remaining concentration of A is now A minus X and that of product is X. Okay. Then, so as it is a second order reaction, okay, as it is a second order reaction, the rate expression, that is dx upon dt, is equals to k2 into a minus x to the power 2. इथे दोन कशामुळे? Because it is a second order reaction. K2 इथे denotes करतो rate constant for second order reaction. ठीक है. So dx upon dt is equals to k2 into a minus x to the power 2. ठीक आहे, असं सुद्धा तुम्ही लिहू शकता. किंवा तुम्ही जर से काय केला, से a plus a gives product. ठीक आहे. Then at t is equals to 0, it is 0, and at some time t, it is remaining concentration is a minus x, this is a minus x, this is x. So rate expression is equals to dx upon dt is equals to k2 into a minus x into a minus x. Okay, or k2 into a minus x to the power 2. Okay, असं सुद्धा लिहू शकता. Okay, so dx upon dt is equals to k2 into a minus x to the power 2 or square. ठीक आहे. Then as usual, जसं zero order first order मध्ये आपण केलं तसं इथे सुद्धा पुढची स्टेप आहे सेपरेटिंग variables. Separating variables. तिथे x चे टर्म आहे, तिकडे x चे टर्म, t चे टर्म एका साइडला. So dx, okay, a minus x to the power 2 हे is equals to k2 into dt. हे झालं separation of variables. Then next, एकदा separation झाला की on integration. So on integrating, याचं येईल integration of dx a minus x to the power 2 is equals to, आता k2 constant आहे बरोबर, तो इंटिग्रेशनच्या बाहेर आहे, इंटिग्रेशन ऑफ dt. आता 1 upon a minus x square चा आपण इंटिग्रेशन घेतलं. ओके, सो इट इज इक्वल्स टू 1 upon a minus x is equals to k2 as it is dt child t आणि plus c, which is integration constant. You can give it as equation number 2, this one as equation number, this one as 2, this one as 1. ठीक आहे. काय केलं आपण? dx upon dt is equals to k2 into a minus x square, separating variables, x चा टर्म एका साइडला, dt चा टर्म एका साइडला, दोन व्हेरिएबल आहे x आणि t. Okay, so therefore separating those, then on the integration, so integration of dx upon a minus x square is equals to k2 into integration of dt. Therefore याचं इंटिग्रेशन येते 1 upon a minus x is equals to k2c plus k2t plus c, where this c is integration constant. What is this? C is a integration constant. Now last time just आपण c ची व्हॅल्यू फाइंड आउट केली होती. ओके, सो हाऊ डिड यू c ची व्हॅल्यू कशी फाइंड आउट करतो आपण? व्हॉट वी डू, so to find the value of c, put initial conditions. Okay, so to find the value of c, we put initial conditions at t is equals to 0, x is equals to. So to find value of c, put initial conditions. Okay, so at t is equals to 0, x is equals to 0. Okay. So 1 upon इथे a minus x आहे, तर जिथे x असेल तिथे किती 0 ठेवा. It is 1 upon a minus 0 is equals to k2 t च्या ऐवजी येईल पुन्हा 0 plus c. तर c ची व्हॅल्यू किती येईल? c is equals to how much? 1 by a. Say it as equation number 3. Okay, so you got the value of c as 1 by a. Now put the value of c as 1 by a into this equation number 2. Therefore, from equation number 3 and equation number 2, we get 1 upon a minus x is equals to k2t plus c च्या ऐवजी 1 by a. So k2t is equals to 1 by तिकडे जाईल. It is 1 upon a minus x minus 1 by a. बराबर. a plus a इकडे गेले की minus होईल. So 1 upon a minus x minus 1 by a. So simplify it. तर काय करणार? Cross multiplication. a minus now a minus x divided by a into a minus x. So k2t is equals to a minus plus x a into a minus x. A plus a minus a cancel with. It will be x divided by a into a minus x. Finally, k2 is equals to t ikkade ana 1 by t into x divided by a into a minus x. Set as equation number 4. This equation number 4 is nothing but integrated rate expression for second order reaction. Okay, any problem? See, product a plus a gives product at t is equals to 0. Initial concentration where a and that of product was 0, and after some time t, reactant react to form product. The concentration of reactant decreases. Remaining concentration after time t is a minus x and a minus x, and that of product is x. So as it is a second order reaction, you can write rate expression or rate law as dx upon dt is equals to k2 into a minus x into a minus x, or simply a minus x into a minus x is a minus x square. Therefore, dx upon dt is equals to k2 into a minus x square. Next step is usual separating variables. X च्या terms एका साइडला, t च्या terms दुसऱ्या साइडला. So dx upon a minus x square is equals to k2 dt. Then next step is same integration. So on integrating, so this is infinite integration. So dx upon a minus x square is equals to k2 into dt into integration of dt. Integrated याचा integration येते 1 upon a minus x dt च्या t k2 as it is infinite integration. Therefore, put the value of we have to introduce value of c and integration constant. Then to find the value of c, we put initial conditions at t is equals to 0, x is equals to 0. So by putting these values, we get value of c as 1 by a. Put this value of 1 by a into this equation, we reach it up to this point, that is k2 is equals to 1 upon t x divided by a minus x. So this is integrated rate expression for second order reaction when concentration of both reactants are same. Okay, so I think we stop here.
Hello.
Thank you very much, sir. If the
Yes,
participants
sir.
don't have any query for this chemical kinetics, they can ask sir directly. And this is the important topic. This topic very, even though in my UG I have learned the chemical kinetics, but uh, at that time I wasn't understand the chemical kinetics actually, sir. The first and second order reaction also even. But now today by attending, I think that we have almost spent 2 hours in this session, and I or other student may never get bored for this session. And this is a in the point of not only the chemistry but for the life science student also. This topic is very important. So I thought that many of the ideas about this chemical kinetics for about the first order, second order reaction, the student may got clear there. If the student, even the student have any query, they can ask, sir. Do student have any query? I thought that if you have any query, you can go to our YouTube channel there. This video is available there. You can put your queries in chat box. The sir will directly reply you with the chat. Okay. So now we are moving toward the final session of this 6 day. To propose vote of thanks, I call upon my colleague Dr. Mr. Gajanan Kotapalli sir to propose the vote of thanks. Kotapalli sir, over to you.
Thank you, Dr. Arvind Chauhan, sir. Before I cast a vote of thanks, we have with us from last 2 hours Professor Patwari sir. So I request to Professor Patwari sir, please give any suggestions. Sir, are you audible? Hello.
So let them unmute, make go so he can unmute himself. Patwari sir, you can unmute yourself right now.
Hello, sir.
I think he's not able to unmute himself. Actually, we have logged the meeting to unmute by the to the participant. That's why.
Okay, let us move towards the vote of thanks. So
wait a moment, sir.
Yes.
Yes.
Hello.
Yeah, Patwari sir.
Yes.
Yes, sir. Yes, sir.
Yes, I am talking.
Yes, sir.
Pathan sir. Yes.
Yes, sir. Yes.
Pathan sir. Yes. Yeah, you are nicely explained all aspects regarding chemical kinetics. Thank you, sir. Starting from rate of reaction, order of reaction, molecularity of reaction, zero order reactions, first and second order reactions. Nicely explained you are. Congratulations from me, and also congratulations to Chavan sir to start this activity. Thank you very much.
Thank you very much, sir. The support from you people is used to us. That's why we are able to, we are able to conduct such kind of activity for our students. And this activity not only for the April, sir. We are likely to be continue this for May and June also.
Okay.
Yeah. With you people support only, sir.
Okay.
Yes, sir. Thank you very much, sir.
So
yeah, Kotapalli sir.
Thank you, sir. Now let us move toward the vote of thanks. In today's session, Pathan sir very nicely presented the chemical kinetics, and in his presentation, sir covered the rate of reaction, rate law, factors affecting for rate of reaction, molecularity of reaction, order of reaction, and particularly in order of reaction, zero order reaction, first order reaction, and second order reaction having equal concentration. So thank you very much, sir, for your giving valuable time for us, and also thanks to all the participants who have actively present for this presentation. So on behalf of Department of Chemistry, IQSC, and on behalf of our college, I thanks once again to Mr. Pathan sir, and from last 2 hours we have Professor Patwari sir with us, and I also thanks to Patwari sir for giving a suggestion for us. So thank you once again, one and all. And with this, I conclude that this session will be concluded. Chavan sir?
Yes, sir.
Second portion,
Yes, sir.
second
Thank
part,
you, Dinesh sir.
Yeah, hello sir.
Pathan
the
sir.
second portion will be conducted in another session.
Sorry, sir.
Remaining portion of the unit will be conducted in another session.
Yes, sir. Definitely, sir. Definitely. The remaining part of this chemical kinetics we will conduct in another lecture. Similar, we will communicate you, and it is a request to all the participants. Please give feedback over today's both the session. We will share you the feedback link in our our chat group on the WhatsApp as well as in the Telegram. So it will. Thank you. Give us 2 minutes of time to give your feedback. This session is over here, and tomorrow we will be tuned at not on the tomorrow. On the Monday we will tune at 10 o'clock morning. Thank you. Thank you very much, sir.
Thank you.
Thank you very much, sir. Pathan sir.
Thank you.
See you again.